Alright, so here we go on our lesson about the greatest common factor, otherwise known as the GCF. After today's lesson, I will be able to find the greatest common factor of a set of numbers. And then this is important because we want to be able to simplify and work with fractions in a much easier way, and being able to find the GCF will allow us to do that. Alright, so first and foremost, what is the greatest common factor? Well, if you break down what each of the words means, greatest being the biggest or largest, common meaning the same, and factor being a whole number that can divide another number without a remainder, if you put all these pieces together, you get that the GCF, there we go, the GCF is the largest factor that two or more numbers have that is the same. Right, so for example, if I have 12 and 6, if I look at 12 and 6, I know that the greatest common factor between the two of them would be 6. And we'll look at how to do that. Alright, so first what you can do is you can list all of the factors. Okay, so we're finding the common factor, the greatest common factor of 16 and 24. And so I'm listing those factors, so 16 and 24, just make sure you know where we're looking. And I know the first factor is always 1, right? And then I have 1 and 16, 2 and 8, and then 4. And then I'm also going to list my factors of 24. In this case, those factors are 1, 2, 3, 4, 6, 8, 12, and 24. All right, and then we start from the bottom. Actually, we can start from the top and we can work our way down. 24 isn't even a common factor because it's too big to have in common with 16. 12 is not in the other. 12 is in 24, but it's not in 16. Okay, so then we know it's also not 16. But here we have 8 and we have 8. So in this case, the GCF is equal to 8. Ooh, that's a horrible 8. There we go. Now, if you look at these other factors, yes, they have other factors in common, and those are just called common factors. So any factors that two or more numbers have that are the same. The greatest common factor, though, has that little bit of difference where we're talking about the largest factor. All right, the second method that we have is called the ladder method. All right, so we're going to use the ladder method to help us find the GCF of 12, 18, and 60. So to do that, what I do is I write down my numbers, and then I put them inside of a ladder. All right, so I put them here, make my little ladder, kind of like an upside-down long division symbol, but with more numbers in it. All right, and then first I begin with a prime factor that divides into each number. Keyword here being prime. Okay, and I could use 2, so I'm just, I know all of these are even, so I'm going to go ahead and I'm going to use 2 because I know it's prime. 12 divided by 2 is 6, 18 divided by 2 is 9, and 60 divided by 2 is 30. All right, now I look again and I look to see, do any of these, or do all of these have a common prime factor? In this case, they can all be divided by 3. 6 divided by 3 is 2, 9 divided by 3 is 3, 30 divided by 3 is 10. All right, now I look again, and the greatest prime factor that these all have in common is 1. Now that we've gotten down to 1, we know that we're done. So what I'm going to do is I'm going to take these outside numbers, and I'm going to multiply them. So I have 2 times 3 times 1. I know 2 times 3 is 6, times 1 is 6. So the GCF of these three numbers is 6. Alright, so we have Kim, who's making floral arrangements, and she has 16 red roses and 20 pink roses. Each arrangement must have the same amount of pink roses. Each arrangement must also have the same amount of red roses. What is the greatest amount of arrangements that Kim can make if she uses all of the flowers? All right, so our question, what is the greatest amount of arrangements that Kim can make if she uses all of the flowers? Key point, she has to use all the flowers. She has 20 pink roses, and she has 16 red roses. And another part here is that she has to use the same amount of pink in each arrangement and the same amount of red in each arrangement. So that means if she has 3 red in this arrangement, she has to have 3 red in this arrangement as well. Okay, but she can have 3 red and 2 pink. And 2 pink, it's not that the red and the pink have to be equal, it's that the reds have to be equal in all of the arrangements. All right. So, since we're looking for the greatest amount of arrangements that she can make, what we have to look at is how can we divide up each of these numbers and make sure that we use all the flowers and use them all evenly. So I'm going to look for the greatest common factor, as I just tried to write greatest common factor instead of 20. There we go. Okay, because each of these numbers can be divided, so I could make, with these 16 flowers, I could make one large group with 16 flowers in it. Okay, and I can make one large group with 20 flowers in it. So I can put all these flowers into one group. However, we want the greatest amount. So she could make 2 groups with 8 flowers. She could make 4 groups with 4 flowers. She could make 8 groups with 2 flowers, or she could make 16 groups with 1 flower each. Okay, now looking at the 20, she could make 1 arrangement of just 20 flowers. She could make 2 arrangements that have 10 flowers each. She could make 4 arrangements that have 5 flowers each, or she can make 5 arrangements that have 4 flowers each. She could make 10 arrangements that have 2 flowers each, or she could make 20 arrangements that have 1 flower each. Now the thing is, she wants to make, in order to use all of them, she has to find a number that both 16 and 20 can be divided by, and it wants to be the greatest because of the fact that we want the most amount of arrangements. So we know she can't make 20 groups because she doesn't have 20 of her red roses. And it can't be 16 because 16 is not a common factor of 20 and 16. It can't be 10 because 10 is not a common factor of 10 and 16. It can't be 8. It can't be 5. But it can be 4. So the greatest amount of arrangements that Kim can make there we go, is 4 arrangements. Each arrangement, now we're going to take this a step further, since she's making 4 arrangements, what we can do is we can take those 16 red flowers and divide it by 4, and we know that there are going to be 5 red roses in each, and then take 20 pink roses and divide it by the 4 groups, and we get 5 pink roses each. So then we know that each arrangement will have 4 red roses and 5 pink roses. All right. So that's all I have for you on our lesson today. What I would like for you to do is you have a little bit of extra space down at the bottom. I would like you to find the greatest common factor of, let's do 36 and 16. And let's do 45 and 12. And then we're going to do a group of 3. So let's do 24 36, and 48. And I want you to try both methods. All right, so for 36 and 16, I want you to do the ladder method. For 45 and 12, I want you to do the listing method. And then for this one, it is your choice of whichever one you like better. All right. Then when you come back to class, we'll take a look at your answers. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.